Welcome to the OpenGL In-Depth Part 2 VTM series. For those of you that have this series, you have probably identified the fact that it's long.
Very long.
It's so long. At first it was going to be 2 different VTMs, and we decided to put it all together as one giant monster.
It was going to be 2 hours each.
That's right. But then we took this one giant monster and we broke it up into 2 parts. Kind of like 2 VTMs.
That's right.
But instead of having it titled as VTM 1 and VTM 2, it's now just simply called OpenGL In-Depth. Now, in Part 1, if you guys recall, we talked about a lot of things. We introduced you to OpenGL and the rendering pipeline. We moved from there talking about how we could utilize OpenGL with various window interfaces. We took a look at GLUT, SDL,
WX widgets,
Windows
API,
and the Windows API. Well, that was lots of fun.
Oh, yeah.
With about 600,000 things that needed to be set up. We then moved from there into talking about creating geometry, manipulating that geometry, texturing, some lighting. We took a look at, what else did we take a look at?
Well, we created a particle engine.
Created a particle engine. That was definitely cool. We created a scene hierarchy or a scene tree.
We did a lot
of different things. That's a fact. And an OBJ importer.
Importer, right.
Yeah, and a viewer for what you've imported as well. So, yeah, very, very incredible first part. For Part 2, we're not about to slow down. We've got a lot of things to show you guys. A lot of these things are going to start teetering on advanced subjects.
Yep.
And because of that, obviously, we're going to have to do a more discussion-based approach in those particular lessons.
Yep.
Otherwise, we'll end up with an extremely long VTM. Right
40-hour long VTM.
The goal is to keep it at 20 to 21 hours. I'm pretty sure we're going to end up going a little bit over that. But again, that's kind of the goal. We want to keep it around that area. Let's go ahead and move to the next slide where we can show you what we're going to be discussing. We're going to talk about anti-aliasing techniques. We're going to talk about curves. We're going to also even write a curve program as well.
Yep.
We're going to talk about optimization techniques. We're going to look at BSP trees. We're going to look at oct trees and quad trees.
Yep.
We're going to look at reflections, and we're going to write a little reflection program, if you will, so we can take that SDL demo that we've been working on in Part 1 and add a floor in and then have our cube reflect in the floor. Unfortunately, reflections and shadows, they're not available in OpenGL.
Nope.
We can't just simply turn those on and they magically appear.
GL enable GL shadows.
Yeah, that would be really nice. Unfortunately, that's just not the case. So we have to perform miracles. We have to perform tricks and hacks to pull off these illusions. And we're going to talk about them. And with reflections, we're going to utilize the stencil buffer in creating a reflection for you guys.
Right.
And then with shadows, it gets even more complicated. So it's just going to be a discussion about a particular shadowing technique called volume shadows. And we're going to talk about how we can use the stencil buffer for, again, creating the illusion of shadows being there. And then we're going to point you to some great reference material. Yeah, so that you can continue your research with real-time shadows. From there, what we're going to do is provide a nice look at shaders. And this is going to be comprised
meaty
of
look at shaders.
Several different videos. We're going to start with a shader overview, talking about what exactly shaders are and how they fit into the rendering pipeline. From there, we're going to move on to RenderMonkey, which is the IDE we have chosen for the creation of our shaders. So we're going to introduce you guys to this. It is a free IDE made by ATI. We'll get it set up, and from there we'll write a very basic shader. Once we've got the shader written, obviously the next step is how do we get that shader over into our own C++ applications. So we're going to use Glue to help make this a simple process.
Right.
And we'll talk about that when we get to Glue. But basically we'll walk you through where to get it and how to get it set up. And then we're going to do shader implementation. We'll bring our shader in and we will shade up the cube that's in our SDL demo using this per pixel shader. Moving on from there, we're going to create a shader class, because when we do the shader implementation, it's really going to be kind of a straightforward, linear type approach.
Right. It would only really work if you had one shader.
One, maybe two.
Maybe 2 shaders.
But the moment you have 3, 4, 5, 20...
It just isn't practical.
No, you would not want to use this approach. But we're taking this approach because it does simplify the learning process of what's involved in getting a shader into your own custom application.
Right.
After we've looked at that, though, we're going to create our own shader class, which will make dealing with shaders, simply put, is dealing with objects.
Right.
So if we have created a new Phong shader, that will be an object. Create a new Lambert shader, that'll be an object.
All we need to do is say, use this shader.
It'll be an object. That's right. So we just create instances of the class and then just use them as we need too. So that's going to be really cool. Once we get that in place, then what we're going to do is jump back over into RenderMonkey and get a little bit more involved with the shader creation process. We're going to write a Phong shader from scratch, which will be really interesting. So you guys will actually see us revisiting the lighting section that we talked about way back when we introduced the Phong lighting model.
Right.
And then we'll see it in action, and we will build it line by line, which is going to be really cool. From there, we're going to introduce bump mapping. In this particular case, we're going to use a more modern approach, which will be normal mapping. And we'll use a normal map that we've got that comes with RenderMonkey, and we'll show you how to set up the math that's required to make it work. And then we are, of course, going to bring that over into our custom application using our shader class to apply it to our cube.
Which will turn out to be very, very simple.
Yep. And then from there, we're going to jump back over once again into RenderMonkey, and we're going to spend a little bit more time just playing with shaders. We're going to talk about how to do things like light intensity, light color, because lighting in OpenGL is now out.
Yep.
The moment we start using per pixel shaders, now
we have to worry about
That's
everything.
right. It's all within the code of the shader. So we're going to talk about doing things like that. Then we're going to get really cool, and we're going to show you how to manipulate vertex locations with the shader, the vertex shader.
Right.
And then we're going to talk about working with time as well so that we can have animated effects within our shaders. Once we get done with that, we're then going to move into the FBX importer, which is simply a bonus for the OpenGL in-depth VTMs. Again, it's just a bonus. We're going to show you guys how you can write an FBX importer, which will take FBX files which contain geometry, texture, boned information, skinning information, animation, lights, all of that, and bring it into our own custom application and then massage it into our own data format.
Right.
And with that, that'll wrap up the VTM. So a
lot
lot of content coming your way. So buckle up, get ready, and here we go.